Pemirsa UBTV, Fakultas Teknik Jurusan Teknik Pengairan Universitas Brawijaya kembali menggelar International Conference of Water Resources Development dan Environmental Protection. Kali ini menghadirkan 4 pembicara dari Jepang dan Malaysia. Berikut liputan selengkapnya.
Please sit. Before continuing the opening program, we broadly present traditional dance Sri Pangranti. Ladies and gentlemen, please welcome and big applause traditional dance Sri Pangranti. Enjoy.
His Excellency from OEC, from Kobe University, and His Excellency Professor Imai from Yamaguchi University, His Excellency Professor Farida Osman, who is my advisory as I'm a student in Malaya University, and Excellency Professor Amir Hashim from University Tun Busenon. Thank you very much for your willingness to come in this conference. And thank you for my colleagues in department in University Brawijaya and another faculty. And thank you very much for presenter and participant and all of you guys of this conference. The conference was organized by Water Resources Engineering and collaboration with University of Malaya, University Sains of Malaysia, and University Tun Busenon Malaysia. As a head of Water Resources Engineering Department, I would like to express my deepest gratitude to Rector Universitas Brawijaya, Dean of Faculty Engineering, keynote speaker, International Advisory Board member, organizing committee, my department, and all participants present, and also my students that support the successful of this conference. This international conference is our department, and expect that we plan this conference into our activity every 2 years. Ladies and gentlemen, before that, as a responsible of the conference, I apologize if any inconvenience of the organizing this organization. The final word I would like to Prof. Bisri, as the Rector of Brawijaya, to be willing to officially open this conference. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. May peace be upon us, the Honorable Professor Oishi, Professor of Kobe University, Japan, Professor Tsuyoshi Imei, Professor of Yamaguchi University, and Associate Professor Dr. Farida bin Usman from Malaysia, and then Professor Dr. Amir Hashim, Professor of University Tunisia on Malaysia, Dean of Faculty of Engineering, Dr. Surbitoyo, Head of Water Resources Engineering Department, Dr. Solihin, and Professor Suharjono, my teacher. Distinguished authors, presenters, and participants, first of all, I would like to express my gratitude to every participant of this conference, and also welcome to Indonesia. Welcome to Malang, and also welcome to our campus, University of Brawijaya. University of Brawijaya has established since 1963, or University of Brawijaya, SIM of UB now. UB campus is situated in the city of Malang, East Java, and now we have more than 60,000 students. It's very big in Indonesia, so maybe in the world. We have 20 faculties, 2 faculty of level programs, 1 vocational program, and 1 postgraduate program with more than 160 study programs, consists of diploma program, bachelor's degree program, master degree program, doctoral program, and medical specialist program. In this year, we are proud that the public has trusted us as one of the qualified university in Indonesia. This from Indonesian National Accreditation Board with an A score. We also placed in the 4th rank after Gadjah Mada University, University of Indonesia, and Institute of Technology Bandung, and we are in the world university rankings at about 700. I want to support the vision of the Resources Engineering Department is organizing this international conference. This conference is appropriate with the University of Brawijaya vision and mission, which is becoming an outstanding world-class entrepreneurial university. Internationalization is the next step of the development. Water resource engineering is nominated by the Faculty of Engineering to process the KE certification this year. This conference is also the effort to internationalization. On behalf of the University of Brawijaya, I would like to thank the International Advisory Committee, keynote invited speaker, organizing committee, and our sponsor who make this conference possible. I wish you all to have a fruitful conference and enjoy your stay in Malang and explore the Indonesian cultures. Hopefully, through this conference, it hopes that the young scientists called bring the latest research and create the integrative understanding of what research can be informed. Ladies and gentlemen, let me close this with final thoughts. Let us make benefit in the conference by bringing together young scientists in many fields related in water resources from physical, biological, chemical, social, and governance term to discuss solutions for better environment and water resources. Let us work together to advance the solution for better environment and water resources and thus remake the world anew. And with this sign, this conference is officially started. Dan saya ucapkan Bismillahirrahmanirrahim. Maka the first Young Scientist International Conference of Water Resources Development and Environmental Protection saya nyatakan dimulai. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Okay, I think this brief introduction, and according to our schedule, we will have almost 1 hour for having a lecture and some discussion at the end of this lecture. So let's start this. Maybe Professor Oishi, you have 45 minutes, and then we will have a discussion later on. The time is just this.
Selamat pagi. Saya Satoru Oishi. Saya orang Jepang. Saya sudah malam 20 kali 15 tahap. Saya tidak bahasa Indonesia bisa. I would like to speak in English. Sorry. So before I talk, I would like to show my sincere appreciation to Rector of University of Brawijaya, Dean of Faculty of Technique and Head of Department, and Professor Suharu Jono, and distinguished guests, and organizing committee, Dr. Dian Sisingi, and all of the participants for inviting me and giving me a very nice opportunity to show my related to latest research. And it worked in the Indonesia. Most of the part, not only the field but also the human resources. Our research result depend on the Indonesian students. And so, as moderator Dr. Dian Sising mentioned, I'd like to give a lecture and keynote speech about the utilization of XMP radar for monitoring and preparation of short-term rainfall and its application. And before the talking inside the very technique, I'd like to give latest issue of the disaster prevention. And after 2011 Great East Japan earthquake and tsunami, we call it as GJ. We are concerned about the resilience. And there are two meanings in the resilience. One is the ability of the substance or object to spring back into shape or elasticity. So it means the softer material like my glasses, elasticity, and it changes the shape easier but reflects that shape soon. And the other is the capability to recover quickly from difficulties, and in the other words, toughness. Sometimes we make it into mix, and strong and soft is resilience. by showing this picture, I'd like to say what is the resilience. This is the image of the graphics which has a resiliency. As you watch this picture, nowadays the shape is easily changed, but soon it's come back, the original shape, and we call it as this grass has a resilience. Somebody wanted our society to become such a society to happen. After happening, it becomes easier. However, before us, we are assuming about the hazard and protect from the hazard. This is a cartoon coming from the Attack on Titan, which is now a very big move in Japan as well as in the world maybe. This cartoon and animation shows a very big man, but the wall itself has no resiliency. If they attack the wall and certain times and it destroyed, and human society must go back. So which is our image of hazard? And so by preventing that damage, we define this kind of equation. This equation is coming from Professor Hayashi. He's a professor of Kyoto University. D equals the image, damage. Damage is a function of hazard, export, and vulnerability. Hazard is amount of the force of the natural things, and exposure is our human society's exposure, and vulnerability is inside our human society. I went to several countries in Asia, and some of them are very not so well sophisticated to prevent the damage. So in that area, we have big hazard, high exposure, and high vulnerability. This photo taken from the bank toward the river. So these houses are inside the river. So naturally, after the flood, these houses should be drowned and sometimes flushed off. So it means the hazard is very severe, exposure is very high because there is no prevention, and congesting makes a vulnerability when they realize that flood is coming, but this congesting prevent them from evacuate quickly. So this is I guess that this is the worst for disaster prevention, and we have to make some kinds of civil works or urban planning to avoid this kind of situation. But once we already getting up from that kind of stage, we realize that our prevention is not enough. So this is the Japanese river. We call it as Waju embankment system. Waju is the embankment which not dividing the river from the society, but like as castle, that embankment surrounded the society, like here, surrounded the society to protect the society itself, not considering about the river's movements. It has some kinds of resiliency because there is a river inside the embankment, and the embankment is sometimes cut off at here, and the water coming from the river suddenly disappeared by this river. So it is a kind of resiliency. We manage this kind of resiliency from our historical work. However, sometimes we assume that the 100% protection, so we made such kind of tsunami embankment, tidal embankment. And this photo is taken before 2011 great earthquake and tsunami happened. But afterwards, that embankment is completely washed off, and all the water coming to the town, and 2,000 of people passed away by the disaster, not including the nuclear power plant accident. So we come back to the historical work, which gives, so to solve that question, we have a new philosophy to avoid fatality. This is also the equation coming from Professor Hayashi, Kyoto University. Resiliency is defined as a damage, which is hazard, vulnerability, and exposure. And A is a human activity. We have to move, we have to evacuate. The T is a time to recover, he said. And this figure shows a good image of the human activity. Professor Katada in Gunma University, he's also a civil engineer, but he taught the elementary school and junior high school students to evacuate by themselves as soon as possible and as far as possible. And it made no casualty happen this time in Kamaishi. So evacuation is really nice. And there is another example. It shows an Ontake volcano eruption. Mount Ontake has erupted in 2014 without any notification. So many people had their crying, and many 50 people passed away by this eruption because they involved into volcanic ash. He is a person who conducted rescue, who is conducting a rescue. He says survival triangle as a key idea to save your life under natural hazard. His name is Mr. Sato. The survival triangle consists of recognition, knowledge, and equipment. Recognition is the ability to understand the situation, what's happening. Knowledge is the knowledge to imagine what happens next. And equipment is the material to protect yourself. So he says, if we have a stronger, larger triangle in terms of recognition, knowledge, and equipment, our life is safe. Otherwise, we are not sure after something happens. And after we are thinking about Mount Ontake, before the eruption, that Mount Ontake was such thing. It's a beautiful autumn, changing the color. Everybody wants to climb to watch that very beautiful scenery. However, if we know before eruption, nobody wanted to climb. So the reason why there are many climbers on the Mount Ontake is most of the climbers did not aware the mountain is volcano. So it means the survival triangle is very, very strong, small at that moment. Most of the climbers did not aware the mountain is volcano. Therefore, most of the climbers did not imagine that big stone. This smoke is not smoke, but they consist of huge stones which attack him, and soon he passed out. And most of the climbers did not prepare a hurricane to prevent his head from the attacking of the stone. So most of them did some kind of attitudes by which is taking a photo, taking a photo. This movie shows. Okay, yeah. It is post-disaster. Almost all the area is covered by ash, but before it was a very beautiful mountain. And this photo, this anime shows just after the eruption happened, people taking photo of that smoke to show it on the internet by YouTube or something. During taking photo, that smoke comes into them, and some of them pass away by that attitude, which means the preparation is not well for them. So this kind of YouTube movie shows how they didn't know that a mountain is volcano. So what if we did have known the eruption and climber would not have climbed the mountain, then there would not have been any casualty. So prediction is very important to reduce the casualty. However, nowadays volcanic eruption and earthquake are very difficult to be predicted. In terms of the water-related disaster, it is not so much difficult for us to know what's happening by using radar. So this is an image of radar. In this figure, I show this kind of figure. In this figure, red color shows huge amount of rainfall is now happening. It is in the Osaka Bay area. The Kobe is located around here. It shows the movement of the rainfall. And this figure shows the movement of the rainfall gradually going to the right upper portion, right upper parts of that moon. It means northeastern world. And by watching this kind of figure and animation, you can identify when the rain comes and when it's finished. And during the rain, we must not go out. We have to prepare our houses, pressure things to be up, and so on. So preparation can be done because we know what's happening now by using radar. So by using radar, I can say not so much difficult to predict the water-related discharge. And I want to utilize that kind of newer technology in Indonesia. So now I'm talking about XMP radar, which is my main subject. XMP radar stands for the X band, which is 3 centimeters of radio microwave multi-parameter radar, which using what is multi-parameter, which using the both horizontal wave and vertical waves. They use also the difference of received parameter and phase. So they both use the energy and phase of the signal. Fortunately, very fortunately, by using the Indonesian students' help, we developed an XMP radar in Kobe. This is a newspaper which shows our radar is now, not now, but on the sale. As you know, Kobe University is accompanied with Furuno company. We developed a radar. And this photo shows me to explain to the newspaper caster. This radar is very small but fully functional. It is 1 meter, 1 meter, 1 meter, and 100 kilograms. And it divided into 3 parts, so we can bring it by ourselves. Previously, this kind of radar was bigger, 2 meter, 2 meter, 2 meter, and 2 ton, 2,000 kilograms. So it requires heavy machines to install, but our radar just put it on by engineers only. And not only that smallness, but also the space and time resolution of our radar is very nice. I would like to show our area. This is the area of movie, which is Osaka Bay. Kyoto is right here, and Osaka is here. Kobe is located close to Osaka, and there is Awajishima, and Kansai Airport is over there. So this is the area, and I would like to show this kind of image. Left-hand side is a bird's eye view, which shows a volumetric image or a 3D image or a height of the rainfall. Not only the plane view, but also height is obtained. And right-hand side is the plane view, which is movement, which shows the movement of the radar. And if we have a heavy rain, it shows a red color. If we have a small rain, it shows blue color. So blue is small, yellow, and red is big rainfall. This video shows our doing, what we are doing. The videos and radar simultaneously observe, and we detect the number of drops. This is a picture of drops. It consists from raindrop and ice drop, frozen drop, grapples, snow, ice crystals, and so on. Even in Indonesia, above the air, it consists of icy drop. This video shows about 4 kilometers of the altitude. It consists of icy drop, and the red one is raindrop. This icy drop is a source of rain, and when it becomes bigger, it's falling and soon comes to the ground. So, therefore, we can detect the number, amount of the icy drop. We can estimate the number, the prediction. We can do the prediction. So, I would like to be back to the prediction and resiliency. To get the time t for our resiliency, we have to know that the prediction is not always correct. It's sometimes wrong, or all times wrong in terms of the number. But to have a time for the resiliency and evacuation, so the most severe rainfall which may happen is predicted by using this kind of equation is important. So it may be wrong, but we can prepare. Then nothing happens, we are happy. So this is it. So we developed a 5 ensemble prediction by writing the Hapsari with me by using singular vector or applying on the transition model. So finally, I now apply it into the pedestrian navigation, which gives appropriate time to go back from home and come to the school by using short-term rainfall for examination, for test of our rainfall system, which is developed by the other Indonesian students on a smartphone. So I have no time to say about the volcanic ash detection, which is now conducted on both Semeru, Merapi and Kerut, and if you have some kinds of interesting to that kind of topics, please let me know personally, because it is still under consideration. So I would like to summarize it. Prediction makes time T for avoid disaster in order to be resilient. And prediction requires information, real information, correct information, give better prediction. And now it is available by using XMP radar, and it already set on the Kerut mountain. Actually, the Cerro Jordan are beside the Kerut mountain, and it detects the rainfall movements within the 30 kilometer of radius. Certainty of prediction is available by using ensemble prediction. So I would like to say thank you again for your very kind attention.
Speak there. The name is Associate Professor Dr. Farida Usman from University of Malaya. This is final undergraduate from University of Missouri, Kansas City, USA, and master degree from Newcastle University, UK, and final is PhD from also the Newcastle University, UK, and this member of Asia Pacific Chemical, Biological and Environmental Engineering Society, and also the International Association of Hydraulic Research member, and then is a Malaysian Water Association member. This is the short curriculum video of Professor Farida, and she will be presented. The paper should be titled Urbanization and Water Quality, Cleaning Up Malaysian River of. Thank you. Time is for use.
Talking about the status of the water quality for the Malaysian rivers at the moment, because Malaysia are very dependent on the rivers for its natural resources. Most of our water supply come from the rivers. 95% of our water supply come from the rivers. There is an issue in Malaysia that we need to control, and we also need to preserve and monitor our river basin. I will be looking into the Klang River because that is the most developed river basin in Malaysia. And at the moment, the Klang River is under the stress of urbanization, flooding problem, point source and non-point source. And at the moment, the river is registering class 3 to class 5, which is quite bad in the sense of being the most important water supply for Malaysia condition. Those is the aerosol or water problem. So we have the non-point source as well as the point sources. The non-point source we have from the homes, from agriculture, from the animal side, but also we have the point sources that is coming from the factory, the wastewater treatment plant, the residential area, and so on and so forth. And this condition of a river problem is deteriorated, especially during the normal flow rate or during the low flow. So the dilution factor of the river is very, very low compared to when you have high flow conditions. These are some of the possible point sources that we have collected within the river basin, and you can see there are a lot of point sources. We have registered about 22, but bear in mind this is not the comprehensive list. It is only some of the major components that contributes to the river problem in Malaysia. So as you can see that we have workshop, wet market, petrol station, and so on and so forth. The list is extensive. I just dropped some here, which is the major or the dominant factors that contribute to the river condition. This is how we do the sampling, especially on the load estimation. Most of the point sources go into the primary standpoint, and for the STP, most of the data are collected from the Department of Sewerage in Malaysia, as well as the other point sources we collect the data from the primary standpoint. But the data collected are based on the concentration as well as the discharge load. Those are some of the pictures for the water quality sampling and discharge measurement. And this is quite tremendous because sometimes we have to do at night and so on and so forth to make sure that we have a holistic and full approach for the sampling points. Apart from the primary data collection, we also did some secondary data collections, especially on the NPS, on the loading, as well as how much amount of the surplus of the river is going to support. You can see from here we have some from lobbies, some from the restaurant, and some from the shop, and so on and so forth. Right, once we collect the data, we have to calculate the WQI water quality index. Alright, so in this presentation, I'm not going over the heavy metals and so on and so forth. I'm just going over to some normal parameters because due to short time, I was going to be very limited. And we have also discovered that due to all these CTS mentioned and a lot of activities within the river basin, the Glen River water quality status has been dropped for quite some time. Okay, those are how we calculate the water quality index based on the parameters. And we have the classes 1, 2, 3, 4, and 5. And a part of these classes, we also can classify the river into clean, slightly polluted, or polluted according to water quality index. And you can see from this one, if the higher the water quality is, the better the river is. So we have class 1, water quality is 193, and for class 5, the water quality is less than 21. This table gives you the classification of the water. What is the functional of the river system? For example, class 1, you can drain it straight away from the river, basically, principally. And class 2, of course, you need a little bit of conventional treatment. For the water supply, for class 3, you have extensive treatment. Class 4 is only for irrigation, and class 5 is considered as a dead river, nothing can be done from the river. A little bit of history on the Glen River. In 1976, Glen River was one of the 42 rivers categorized as badly polluted. In 1990, when a similar study was conducted, there is no changes in the status. However, we did recent studies on the trend analysis based on the data from 1997 to 2007, And we have found that based on the statistical analysis, there are some improvement in the water quality of the river, especially at the upper stream and some tributaries. This is the water quality conditions obtained from the Department of Environment for some dominant parameters. You can see that BOD is slightly high, about 14 in some area, and your ammonium nitrate is also about high, more than 1 in some area. And we calculate the WQI for the Klang River for the years of 2005 to 2009, and the range is between the slightly polluted and polluted range, which means that mostly the river is between the class 3 and class 5. More recent data for 2010 and 2011. You can see there are some improvement, especially for the Gombak River. Some of the tributaries are registering class 2. But some of the rivers are still within class 4 and class 5. This is based on the data for 2010 and 2011. Okay, we did some estimation on the sampling that we have done, and it turns out that the main polluter is your S3 or your sewage, which comes to about 80% of the pollutants come from the sewage treatment plant as compared to the rest of the pollutants. So based on this data, you can say that most of the pollutant originates from your sewage treatment. That is the largest contributor to the river system. Okay, based on all the information, the government is very, very worried about the quality of the river system. So they come up with this, what we call as Economic Transformation Program, ETP, in 2010. And one of the programs is River of Life, which has been launched with the aim to improve the water quality of the Klang River. This is a 10-year program. The program is still running. It will end up in 2020. So what I'm going to present to you is some of the initiatives and some of the experience and work that has been done so far in support of this program. Alright, so there is the Economic Transformation Program, which should end in 2020. It has 5 main programs, and the one that we are interested is on the Greater KL and Klang Valley. Under this program, you have 5 entry point projects. So you have 9 entry point projects, and again, the aim is to improve your water quality. So we will be looking into the EPP5, revitalizing the Klang River into heritage and commercial center. But that one is more related to what I'm talking about today. Alright, so those are River of Life, and those are the 2 main objectives. Basically what we want to do for this one is to improve the river water quality from class 3 and class 5 to class 2B, so that we save for body contact and support. And also we want to provide a different level of flood mitigation protection to project area in support of achieving the greater biodiversity status. This is 3 components of the River of Life. We have the river cleaning program, which stretch out to about 110 kilometers, and we have the river beautification program, which concentrates mostly on the KL area. That is about 10.7 kilometer stretch between the Klang and Gombak River near the city center. And of course, the third one is for land development. This is what we hope to get when we finish the program. Rivers that is as nice as the Seoul River, the Venice River, and also Texas River, compared to what we have at the moment. Klang River, this is the current situation, and we would like to transform it into, hopefully we can do that within 10 years. Alright, this the spatial status of the water quality. And there are different colors. As you can see, there are yellow colors, which means that the river is in class 3. The red color means to say that the river is in class 5. And you can see from this map, most of the rivers are in class 3. However, there are stretches where the rivers fall within class 5. So this is the concentrated area that we have to focus on. This is for 2010, and for 2011, some of the stretches has improved to class 2, especially at Sungai Gombak, and the rest still remains in class 3. So these are some pictures of the existing Plain River. So you can see how dirty it is at the moment compared to what we want at the moment. Alright, in order for the government to focus on this ROL, the River of Life, there are 12 initiative description. Of course, the one and the foremost one is to upgrade the existing sewerage facilities, because as I have shown you in the slide before, the sewerage facilities is one of the components that is contributing to the river pollution. And we have a lot of other activities that we have actually come up in the River of Life system so that we can meet the target. I'm going to show you some of these are the agency who will be taking over on each of the initiatives. For example, to upgrade the existing sewerage facilities, we leave it to the Department of Sewerage. And for the wastewater treatment plant, the DBKL, the local authority of Kuala Lumpur is supposed to look into that. So that we have a clear guideline on how and who is doing what and what. Those are some of the structures that has been done in order to improve the river water quality. We have detention pond, we have river beautification. This is the sewerage treatment plant, and also we have some gross pollutant trap with pollutants. Apart from structure measure, we also have non-structure measures, which is basically on the implementation and education and public outreach. Because we believe that the structure measure alone will not work. We have to couple with the non-structure measures. Those are some examples of the key initiatives. The first one is for this treatment of the sewage, treatment of the waste from your wet market compared to your old wet market to the new wet market, where you have the treatment plant to treat your waste. And this is an example of the gross pollutant trap within the KL area. So you can see the different of those. Most of it is to trap your garbage. So we have quite a few within the stretch. Those are the different type of the TPT. It is usually installed near the premises of restaurant, food court, and so on and so forth. This type is usually installed in the monsoon drain, where all your trash is going down, and then it will settle there before it's moved. We also have bigger one. This is meant bigger river basin, mechanical trash. We also, key initiative number 7 is river water treatment plant, submerged biofilter. So you have the treatment plant, which is installed underground to treat your river water. Sorry, this slide is in Malay. But anyway, what it's trying to say is that you have reverse screening of large item, you have the grid, and then go to your biological treatment plant before it's being channeled back to the rivers. Right, those are your plan view. You can see here is your river. We have a view, 1 or 3 along the river system to treat the river water before it channel out to your river bank in order to protect the river from the pollution. So it's just the one section of it, section of view.
Ya, ini kan saya misi UB World Class Entrepreneur University. Salah satu aktivitasnya adalah International Conference. Saya kira cukup bagus karena bidangnya juga menarik, kerusakan lingkungan dan kerusakan aliran sungai ya. Mudah-mudahan ini bisa ada salah satu solusi untuk memperbaiki keadaan Indonesia yang sudah mulai rusak ya.
Now is they are in a developing stage, so if possible, I will there are some help to develop of the level of the water resources. The water resources, as you know, they are very important for our livings. So how to keep the water resources, and of course we discharge the wastewater. So how to clean up, purify of this kind of the wastewater and return to the nature. I see. So nowadays is in the sewage is in Indonesia is not so enough. So how to introduce of the some piping process or some wastewater treatment process in each house or each buildings. So which way is better? I mean to correct and the wastewater treatment or the no correction, and each buildings or each houses treat by themselves is the best way. It's better to concern very well.
Obviously, first thing I would like to thank the organizer for inviting me to this good conference. I'm from University Tun Hussein on Malaysia, from Johor. I will always say I'm very glad because it's a conference which actually inviting all the important people in water resources. So first thing and foremost, I will meet all the specialists, all the scientists and professors in this area. Obviously, we can share our research, thinking, our findings, so that when we go back, we will obviously prolong we will extend our meeting here to really make the water resources a field which is very important in the near future.
Berakhir sudah International Conference di Fakultas Teknik Jurusan Teknik Pengairan Universitas Brawijaya. Semoga bermanfaat untuk Anda pemirsa UB TV. Saya Irsa Rindu dan Andi Kismawar melaporkan untuk UB TV.